Hello. This problem is a power formula question in a combination circuit. We have a source voltage of 120 volts AC. We have three resistors. R1 is in series with a parallel combination of R2 and R3. R1 is 1.0 K ohm, R2 is 2.5 K ohm, and R3 is 5.0 K ohm. Find the power in R2. Okay, so this is our template, and we have R1. Let's start labeling. We have R1 as 1.0. Okay. R1 is 1.0 K ohm. R2 is 2.5 K ohm, and R3 is 5.0 K ohm. It also gave us a source, voltage source of 120 volts AC. And we are to find the power in R2. So that would be this guy right there. All right. So in reviewing our power formula, power is equal to voltage times current. So we need voltage and we need current. We don't have either the voltage or the current. Okay, so we need clues. Well, we have a voltage over here of 120. Our total voltage is 120 volts AC. And we have no other clues. It's pretty empty. What can we find? We know all the resistors, so we're going to have to apply the resistor, add the get equivalent resistor for all three. So we're going to find our total. Okay. The first thing we have a we have a series in combination with a two parallels. So okay. So the first thing we need to do is combine these parallels. Okay, we have a 2.5 and a 5.0. Okay. So we have a 1 and 2. We have a 2.5 ohm, K ohm, and a 5.0 K ohm. Okay, since they're both have the same unit, we don't have to convert them, and we can just use, we're going to use the RAR formula. We're going to take the reciprocal, 1 over 2.5, add that to 1 over 5.0. Again, our answer is going to be K ohms to keep our units the same. So 1.1 divided by 2.5 is 0.4 plus 1 divided by 5.0 equals 0.2. And we're going to add these. So we did the R part. This is the A part. 0.4 and 0.2 makes 0.6. Now we're going to do the last R part. 1 divided by 0.6 is 1.666. We'll round up to 1.667, and that's K ohms to keep the units the same. 1.667. So let's go back 1 point. So in combining these two, we have R equivalent of 1.67 K ohm. Now that is in series with R1, so now we're going to add 1 to that. So we just add them because they're in series. So 1.0 K ohm makes 2.67 K ohm, and that's combining all three. And so that would be our total, 2.67 K ohms. Now we can use our Ohm's law formula. V equals IR. And we take the voltage, we're looking for the I. So we're going to put the R because these are the two knowns. So the voltage is 120 divided by 2. Now we do have to convert because we want units. So that's 2,670 ohms because the answer has to be in amps. So 120 divided by 2,670, and that is 0.0449 amps. Now, from what we know of a series circuit, let's review series. A series circuit, the current is always the same. Current has no choice. No choice. So current is the same all the way around. So if we know this current, that means we know this current, and this current, and this current. Okay. So this current is 0.049. That goes around. Oops. It goes around. And that must be 0.04. But here, it's going to split. So we don't know the current. This one and this one is going to be different. But look what we have here. We have two units. Now we can find out what this voltage drop is going to be. So the voltage drop is I times R. So let's multiply. Be careful with your units. This has to be converted. So I is 0.0449 times 1,000. Okay, and that gives us a voltage drop of 444.9. Okay, now we have 44.9 volt drop across this resistor. So whatever's left is going to go over to these resistors. So 120 minus 44.9 is minus 44.9, 75 0.1 volts. So does this voltage gets divided here and here between R2 and R3? Well, if we review the parallel rules, does the voltage stay the same, or does it divide? Well, it stays the same. Okay, the voltage here stays the same. All right. So getting back to our problem. Okay. So 44.9 volts got used up here. So whatever's left over is 75.1 volts and 75.1 volts. The voltage stays the same in a parallel. Okay, so we don't add these up, it stays the same. So 75.1 plus 44.9 should equal 120. Now, we're still trying to figure out what actually we want to know, the problem is we're trying to find out what the power is here on R2. So now we have two units. We have the voltage and we have the resistance. That means we can find out what the current is, because V equals IR and V over R equals I. So we're going to take 75.1, because that's what our voltage drop is. We're going to divide that by R, which is 2,500 ohms, and 75.1 divided by 2500 is 0.03 amps. Now we have our voltage drop of 75, so now we can use our power formula. Power equals volts times current. Power is equals V times I, or E times I. We know our volts, 75.1 multiplied by our current, and these are units are correct. Amps. Okay, so our answer is going to be in watts. So 75.1 times 0.03 equals 2.25 watts. And that's our answer. Now I'm going to continue filling in the rest of the blanks. Okay, we have power. We're missing a current here. Now notice we have 0.0449 amps going here, and they're going to be split up. Some are going to go that way, some are going to go that way. So how many dropped down? 0.03. How many total are we looking at? 0.0449. So if we subtract 0.0449 minus 0.03, we'll get 0.0149 amps left over to go over here. 0.0149 amps. Now everybody's done except our power. So our power is equal to volts times amps. So let's multiply 75.1 times 0.0149, and that's 1.11, I'm going to round it up to 19 watts. We know what this power is. Now let's do this power. 40, again, power is goes both times amps. 44.9 times 0.0449 equals 2.016 watts. Now if we add those up, now actually we can multiply volts times amps over here. We got 120 times 0.0449, and we get 5.388. Okay. So we have 2 watts here. We have 2 watts here is 2.4. We have 1 watt here. That's 5.38. 0.2. So it looks like it's pretty close. If we add this watt and this watt and this watt, we're going to get, let me switch pens here. Okay. This watt plus this watt plus that watt equals total that. 120 volts went through the circuit. 44.9 was used up here. Therefore, we had a total of 75 left over, which split between the two of these because they're in parallel. In parallel, the voltages are the same, but the current is different. The current cannot be the same. We had 0.03 amps drop this way, and we had 0.0149 drop down this way. If we add those two up, if we went backwards, it started off as 0.0449, which is what we started off over here. Okay, because this way the path was this way. So it went around, then it split, but then they came back. And the same amount of amps going has to equal the amps coming back.